This is free response question number 4 on the 2024 AP Calc BC exam. Okay, so this gives us this graph of f, and it says the graph of f is a differentiable function shown for x is between -6 and 7, has a horizontal tangent at x is -2, and is linear for x is between 0 to 7, so from here to here. Let R be the region in the second quadrant bounded by the graph of f, the vertical line x is -6, and the x and y axis. Region R has area 12. The function g is defined by g of x is integral from 0 to x f of t dt. Find the values of g of -6, g of 4, and g of 6. Okay, so g of -6, we plug in x as -6. So we get integral from 0 to -6 f of t dt. You're probably more used to the smaller limit on the bottom. So you can flip the limits of integration and add a negative sign. Okay, now this guy, integral from -6 to 0, is the area under the curve from -6 to 0, which is r. So we have this minus sign still, so it's minus r. So g of -6 is -12 because they give us r is 12. Okay, g of 4 is the integral from 0 to 4, f of t dt. So integral from 0 to 4, that's the area under the curve from 0 to 4. So we want this area of this triangle. So it'll be half times the base is 4, the height is 2. Half times 2 times 4, which is 4. Okay, g of 6, that's integral from 0 to 6, f of t dt. So we need the area of this triangle and the area of this triangle, but we're going to subtract this area of the smaller triangle because it's underneath the x-axis. It's the sine area. Okay, so integral from 0 to 4 plus integral from 4 to 6, f t dt. I can use properties of integrals to write this. Okay, this we found in this part, so I directly took that. This is just another triangle, so it's half, the base is 2, the height is 1. Okay, but we remember, add a negative sign because we're going to subtract this area. So it's 4 minus 1, which is 3. So g of 6 is 3. Okay. Part B, the function g defined in part A. For the function g defined in part A, find all values of x in the interval x between 0 and 6, at which the graph of g has a critical point. Give a reason for your answer. So to find the critical point, we need to find g prime. So g prime is, I just wrote this from the previous slide. This is the function g, so we want to differentiate this guy. This is fundamental theorem calculus, so it'll just be f of x. Okay, so critical points occur when g prime of x is equal to 0, or it's undefined, but never going to be undefined here. There's no vertical tangent here. Okay, so since g prime of x is equal to f of x, then the critical points occur when f of x is 0. Okay, so that only happens when x is equal to 4. It's only 0 here. Okay. Function h is defined by h of x is integral from -6 to x, f prime of d dt. Find the values of h of x, h prime of x, h double prime of x. So h of x is, again, we plug in x as 6, so integral from -6 to 6, f prime of t dt. You got to be careful, this is f prime. So we're going to use fundamental theorem calculus, the other one, where it says it's f of 6 minus f of -6. Okay, so what's f of 6? That's -1. What's f of -6? That is 0.5. So -1 minus 0.5, which is -1.5. H prime of x is f prime of x. Okay, why do we know that? Well, that's fundamental theorem calculus once again. Differentiate this. You just plug in the limit as your variable of integration times the derivative of this guy, which is just 1. So h prime is f prime. So h prime of 6 is equal to f prime of 6. What is f prime of 6? Well, it's the slope of the tangent line at x is 6. So we can just use this point and this point since those are clearly marked, right? This is 4 comma 0, this is 6 comma -1. So we can find the slope between the 2 points. So -1 minus 0 over 6 minus 4, which is -half. This is a negative slope, so it should be negative. And it doesn't look like it's half because you go over 2 and you go down 1. Okay, now h double prime, what is h double prime? It's the same thing as f double prime. Okay, so because I just differentiated from here. What's f double prime of x? Well, since this guy's linear, f double prime will be 0. Therefore, double prime of 6 is, well, it is f double prime of 6, but f double prime is constantly 0, so it's 0. And that's your answer for part C. So this is pretty straightforward as well. You guys just got to be careful that you have to realize that the second derivative of h is the second derivative of f, and the second derivative of f is 0. And then here you got to be careful. This is one part of the fundamental theorem of calculus. This is using the other parts. Okay, so that's it for this video. Hopefully this was helpful if you're studying for an exam, or if you took the exam this year and you were curious as to the answer for this problem.